Hi guys, it's Cornish Kayak Angler here. In today's video, I'll be running through how to make a waterproof battery box for powering the electronics on your kayak. Perhaps it's a fish finder GPS unit, perhaps it's a lighting rig or any other number of 12 volt devices that you need to supply power to on your kayak. And this particular battery box here, it's one I've been using for many years to power the Raymarine Dragonfly 5 Pro on my fishing kayaks, and it's worked really well for keeping the battery dry and secure in the kayak. However, I've recently brought a new fish finder chart plotter unit. It's got a bigger screen and it's touch screen, so it demands more power. And that means I need a bigger battery, one that will hold more charge than this particular battery here. So in today's video, I'll be making a brand new battery box for that. We'll be running through that in detail. But before I start with that, I'm just going to have a talk about the battery I'll be using, because I won't be using a standard sealed lead acid battery. I'll be using a lightweight lithium iron phosphate battery. So when it comes to powering the electronics on your kayak, the most popular way to do this is using a 12 volt sealed lead acid battery. Really popular, inexpensive, reliable, easy to get hold of. Downside is though, they're quite heavy. Now they're heavy when compared to something that is lighter. Lighter being a lithium battery. So the sealed lead acid battery, this is a 7 amp hour size, really popular size. It's going to power most fish finders for a couple of days before it needs recharging. Yes, 7 amp hour. It weighs, I'll just pop it on the scales here. It's weighing in at 2,175 grams. Now if I just take the lithium battery I've got here, now this is a lithium iron phosphate battery. It's made by a company called Alliant. They are manufactured in Italy, I believe. Really great quality little batteries. Yeah, very lightweight in comparison. This one has a charge equivalent to what a sealed lead acid would give of 24 amp hours. Whereas the sealed lead acid I had here was 7 amp hours. So with the amp hourage, the greater the amp hourage, the more charge it will hold, the longer it will run your device for. With a 7 amp hour, let's just say a device was drawing 1 amp per hour. That 7 amp hour is going to run your device for 7 hours before it needs recharging. With this one here, which has the equivalent of 24 amp hourage, it would be running that same device for 24 hours. Now, massive difference is the weight saving. I'm going to pop this on the scale. So this one, 2,175 grams. The Alliant 24 amp hour equivalent, 1,385 grams. That's a massive weight saver. It's about 40% lighter than what the 7 amp hour lead acid battery was. But let's not forget that's a 24 amp hour battery. So not only is it a 40% weight reduction compared to this standard size battery, it's going to hold nearly 3.5 times the charge of this battery. So it's a massive difference. If we was to get a sealed lead acid battery of 24 amp hour, same as the lithium battery here, yeah, the weight would be just over sort of 7 kilos, whereas this one's just over 1 kilo. We're probably looking at about an 80% weight reduction with the lithium battery as opposed to a sealed lead acid of equivalent amp hourage, of equivalent charge holding. So yeah, it's phenomenal the difference between sealed lead acid and lithium when it comes to weight reduction. Saving weight on big heavy fishing kayaks is, yeah, it's a big thing, especially if you've got a long way to drag your kayak or some steep incline to drag your kayak up after a day on the water. So lightweight lithium, brilliant way to go. Well, there's got to be some disadvantage, and of course there is. 1 being price, 2 being safety concerns. I'm going to run through those now. So when it comes to the cost of these batteries, there is a big difference. You very much pay more for a lot less with lithium batteries. Sealed lead acid battery in the UK here, they're retailing about £20–25. With the Alliant lithium iron phosphate battery, you're looking more towards £200 for one of this size. Now you can get smaller lithium batteries of similar amp hourage to the 7 amp hour here, for less, around the 100 and say 20 to 50 pound mark. So not quite so much as this bigger one here that I require for my new fish finder, but yeah, still quite a price difference, and it's enough to deter many from opting to lithium batteries. But yeah, the sealed lead acids are fine. Yeah, they're a bit heavier, but they're still going to power your device in exactly the same way. But yeah, for those guys out there who want to save weight, or just have a smaller battery that will hold more charge for its size compared to a sealed lead acid, lithium batteries are the way to go. There's various types of lithium batteries. There's lithium polymer, lithium ion, and these ones here, lithium iron phosphate, or LiFePO4. So yeah, these ones are the most popular for marine use because the lithium cells within them are considered more stable than the lithium polymer and lithium ion cells that you'll typically find in other electronics, like your phone. But yeah, these ones here, the lithium iron phosphate batteries, these are the ones that are worth considering if you're thinking of going lithium battery on your kayak. Time to talk safety. Lithium, not only is it a great song by grunge rockers Nirvana, it's also number 3 on the periodic table. It's a lightweight alkali metal, it's highly reactive, and it makes it brilliant for use in battery technology. It's becoming massively used now in a wide range of electronics, from mobile phones, laptops, all the way down to these batteries here, which can be used for a number of 12-volt applications. Now with lithium, if you can remember back to perhaps your chemistry lessons, put lithium with water, you get combustion, often flames, sometimes an explosion. Now we're on a kayak in the aquatic environment, surrounded by water, everything's damp. It's not the best idea to go putting lithium in water or a damp environment on a plastic kayak or any boat of any description. You don't want to go causing a fire when you're on the water. Now, the technology within these lithium batteries now is very good, and these particular ones, the lithium iron phosphate batteries, are very stable lithium cells within here. Still, it's better to be safe than sorry. So putting these within a nice waterproof battery box, which will eliminate the chance of these batteries getting wet, is paramount, and hence today's video of building a battery box. Now with lithium batteries, there's a couple of ways really that you can make one of these combust. Number one is with overcharging the battery. You overcharge it, the current that you're putting into the battery, it's got nowhere to dissipate. What happens is it dissipates as heat. The heat would end up breaking down the lithium cells, probably causing them to combust. Luckily, today's technology with the chargers and the batteries themselves practically eliminates the chance of that happening. There's a microprocessor within this Alien battery, which basically cuts out from overcharging risk. Also with battery chargers, you can only charge lithium batteries with dedicated battery chargers, which will have an auto cut off when they know these batteries are fully charged. So you've got to ensure you're using the correct charger with one of these, and I'll run through that at the end of this video, the battery charger I use. Another way you could get one of these to start combusting, short circuiting. Short circuiting is where the current would jump from one terminal to the other through some medium, water being a really conductive way of doing that, or placing a metal terminal or metal conductor straight across the terminals. You basically get the current feeding itself back into the battery. Again, it just dissipates as heat, could potentially cause those lithium cells to combust. It's unlikely to happen. There's a lot of separation between the terminals on the top of this battery, but not impossible. Not impossible in the wet confines of a kayak hull or on a boat, etc. Hence the waterproof battery box I'm going to be making today will practically again eliminate the chance of that ever happening, to the point where you don't really have to worry too much about using these batteries on the water anymore. They are safe technology used within them, but as I mentioned, better to be safe than sorry, and just know in your mind that everything's good. So now let's have a look at building a waterproof battery box. So just going to run through the components that I'm going to be using to make the waterproof battery box. I've got the Alliant ultralight battery, which I just spoke about. It's a 24 amp hour version. For the actual box itself, I'm using one of these here. It's a lock and lock food storage tub. They're an airtight waterproof tub. Yeah, brilliant for making battery boxes out of. Also make handy waterproof tackle boxes. This one is the model they call the HPL826. It's a 2.6 litre tub, but it's a nice size for housing this battery with a little extra room to put the wiring into as well. But yeah, they're a full clip lid. Clip them off all the way around, opens up. The lid has a nice O-ring rubber gasket, which yeah, sits really well against the tub when it's clipped down into place to make a nice waterproof and airtight seal. So yeah, it's going to make a nice waterproof box to house the battery. Also be using a connector, well, a plug and a socket kit. This is made by Index Marine. They're called a Bolgin 2-pin plug and socket kit. So there's a socket, you see 2 poles there, that'll be for the positive and negative on the battery. Terminals will be connected up to this, and then the corresponding plug kit which plugs into this socket, and that'll be attached to the fish finder power lead, and together, yeah, they sort of screw together, makes a nice waterproof socket there. So it's nice and easy to plug your fish finder into the battery box. So yeah, I'll be installing that onto this battery box. A few other bits. I've got some little terminal bolts. They come with the battery and they're used to attach the wiring to the battery. And I'll be doing that using some crimp-on ring connectors. Also got an inline fuse here which houses a 3 amp fuse that came supplied with my new fish finder. However, they're easy to pick up from chandlery shops or marine stores or any electrical stores. Also be using some super seal connectors to make quick release waterproof connections inside the box, so I can remove the battery from the box easily as well. I've also got a length of twin core wire. I'll just be using some sections of that. I'll be taking this apart, just cutting up some short sections of that to use within the box. Also got some little tiny M3 stainless, 316 stainless bolts, washers and nylock nuts. These are about 12mm long and they'll be used to bolt the socket onto the box. I've also got a block of foam which I'll be using to make a little battery holder within the box to keep the battery nice and secure so it's not slopping about in the box. I've just got some simple tools, a drill with some drill bits, a 22mm hole saw set and some pliers and screwdrivers as well. Okay, so let's start and put together the waterproof battery box. So the first step is going to be to fit the Index Marine Bolgin 2-pin socket to the box. So it's just a case of choosing where on the box you want to fit this. I've had a look in how it will fit inside the Kayak and it's looking like it's going to be best if I mount this on the end of the box. Now the socket supplied with sort of a plastic main housing with some screw terminals on the bottom that we can attach the wire from the battery to, and also a rubber gasket. We can use this rubber gasket as a template to mark out where to drill the hole to fit the connector. Just in case, placing it where you want it, take a permanent marker, mark the very center of where you want it, and also the 4 bolt holes for the connector there. So they're marked up, and it's just a case then of taking a drill. I'm just going to drill and do a pilot hole in that very center hole, and then I can use the 22mm hole saw bit to drill that out. So to do this, I'm just going to hold it firmly in a vise. It's got to be a little careful with the plastic, not to go too fast or too hard into it. Otherwise you can risk cracking it. Just drill a small pilot hole there, and then take the 22mm hole saw bit. We're just going to run that through. Okay, so that's through there now. Just tidy that up. Check the connector fits. It's lined up with the holes that we marked for the bolt holes. And yeah, I'll be using a 3mm M3 bolt, which is a 3mm diameter. So it's just a case of now taking a 3mm drill bit and drilling out those holes for the bolts. Okay, so I'll just show you how that's all done there. So yeah, the main center hole for the socket to sit within, and then the 3 bolt holes to run the bolts through to attach this socket to the box. So that's very much the next step. So we'll pop the lid off for this stage. Yeah, we can take the rubber gasket, pop the connector through. I like to just use a small drop of sealant just around the main hole of the of where the connector is going to run through the box. So this is a little bit of Sikaflex, clear Sikaflex. Yeah, it just helps create a completely waterproof seal between the connector and the box to eliminate the risk of any water finding its way through. So just a little smear of that over where we're going to fit this. Yeah, it's a case of popping it in place and taking our small M3 bolts and popping those through the holes. Just before I pop this final one in, the socket, it comes with a cap, a screw-on cap for when it's in storage. You can screw this in place and it keeps it nice and dry, so you don't get any corrosion on the terminals. But yeah, there's a little hole in the end of the tab, so it's just a case of running the bolt through that before it attaches onto the socket. It's just a case of taking the little washers and nylock nuts, and we can pop those over the threads on the inside and just tighten those up. Okay, so that's the last one now tightened up. We've now got the socket fitted to the box. Some Sikaflex is squidged out around the side so we know it's nicely tightened down, it's all sealed in there. There's no chance of water getting through there. And the cap, screw cap, you can easily just pop on top and screw down for when the connector's not in use. Nice and neat. We can just tidy that up by just wiping off any excess Sikaflex. There we go, that's the connector now fitted. So now it's just a case of wiring in the actual battery. Just going to look at that now. Okay, so it's time to wire the battery up to the battery box. There's nothing too clever that's going to be going on here. It's literally running the wires from the battery to the connector, but also incorporating in the inline fuse. But I'm going to make it so that we can quick disconnect the battery from the battery box, and we're doing that by just incorporating some of the super seal connectors into this setup. Right, so we'll start with the battery. We've got a positive and a negative terminal marked clearly on the battery itself here. We've also got a red cover on the positive terminal there, so I can just pop that off for now. And yeah, the battery is supplied with some terminal bolt and nut kit, and I can literally just use those to bolt on some ring crimp connectors. So what I'm going to be doing, taking a section of some twin core power cable, red and black wires, and I just need to get the wires out from the outer insulation sheath. Might just have to hack away at a little section of it to expose the wires, and you should, with a firm grip, be able to peel these wires out from the outer sheath. So there we go, there's the black and the red wire free. Just got a section there and a section here. Just tidy that up. Now I just need a little short section of red wire to start with. I'll take, say, 5-6 inches or so, 25-30 centimeters, and to one end we just need to strip back maybe 4 or 5 millimeters of cable. You can do it gently with scissors by just slowly snipping around the outer coating, pulling it off, or you can actually use some wire strippers if you have them. There we go, that's exposed now. And with the ring connectors, it's a case of popping the wire over, using a set of pliers or a crimping tool just to crimp that down in place. So it's nice and firmly on. There we go, that's well attached there now. And to the other end I can just strip this off in preparation for the next step. Again, just 4 or 5 millimeters from the end. Okay, so that's one little bit done there. So that's the red wire just done. Now the black wire, this will be running straight to the connector, so I'll actually need just a little bit longer length, so maybe 10 inches or so. Just going to snip that off, and again strip the ends. Like so. Okay, and again to the black end we can crimp on another ring connector. Just put that in place and we'll crimp that one down. Okay, so that's firmly attached there now, that's not coming off. So next it's going to be a case of incorporating some super seal connectors within this setup to make it nice and quick and easy to disconnect the battery. We'll start with the connection between the inline fuse and the bit which will be attached to the battery, to end with a ring connector on. And yeah, I'll be using some super seal connectors. These are 1-pin connectors, really great little waterproof connectors, nice and easy to use and attach to your wires, and nice waterproof fitting too. I've shown installations of these in a previous video. If you want detail on how to set one of these up on your wire, just hit the link at the top of the screen here. There'll be a video there showing you exactly how to wire one of these up. But I'm just going to attach that to these wires now. One joined up. Nice waterproof strong connection, but nice and easy to release, quick release should you want to remove the battery from the battery box setup. So that's one side now done. We can go back to the negative wire, the black wire, and again I want to create a join in this, so I'm just going to do it in the same position as I've got on the red wire. You can just match it up with the other wire. I want to make a cut in the wire in about the same position. Strip back the ends, about 4 or 5 millimeters from each end. Like so. Again, just going to quickly attach those super seal connectors to those ends to make the join. Okay, Okay, so that's the super seal connector joined to the black wire there. Again, I can clip this together. Okay, so that's clipped together. That's the 2 pieces of wire we need to join the battery to the connector that we've just fitted to the battery box now. Let's have a look at that next. Right, just leaves us now to wire up the battery to the battery box with the connector that we fitted, the socket. To do that, it's just simply a case of bolting on these ring terminals to the battery, and then there's some screw terminals on the connector. So we'll just take these terminal bolts that come with the Alien battery, we can undo those. And if we have a look at the terminals, close look at the terminals on the battery, the positive and the negative side, you can slide the nuts into the terminal. Then there's a hole in the top to run the bolt through and through the ring connector. So I'm just going to do that now. I'll start with the negative side, the black side. I'm just going to, as I do this, point the ring connectors towards the connector, just so the wire isn't going to be twisting and bending so much when it's in the box. And he's just do up with a screwdriver. Okay, that's that one firmly attached there. Same with the positive side, just slide the nut into the terminal. Ring connector on top and bolt down through the hole on the terminal. Screw that down in place. So now we're just left with the 2 ends to attach to the socket. If you have a close look at the socket, and there's 2 screw terminals in there. So it's a case of backing off the screws with a small screwdriver. That opens up a hole in the side of the terminal, into which we can slide the wires. If you have a close look, you won't be able to see it on this video, but there's a small L and an N marked or indented next to each terminal. It's just important to make sure you're connecting up. I'm going to connect the red wire up to the L, the live. That when you connect the wire, your fish finder wiring to the socket, you make sure the red is attached to corresponding L terminal on this, so that you've got positive running straight through to positive, and they're not going to go crossing over. So yeah, I've just backed off that terminal. Just in case, taking the wire, slotting it into the hole that's in the side of the screw terminal, and screwing that down firmly into place. Once that's in, that won't pull out there. So that's one side done there. It's attached there. And the same with the negative side. Slot that into place and screw down that terminal. Okay, so there we go, that's all wired in there now, screwed up, connected in. And it's easy enough now just to pop the battery into the box. That's essentially the main part of the battery box done. We could just simply pop the lid on there. That's now a waterproof battery box. However, the battery, you can see it there, wants to move and slop about a bit. So I'll just be finishing off the installation by cutting up a bit of this high density foam block, shaping it so that the battery's got somewhere nice and snug and secure to sit within the box to stop it moving about so much. So I'm just going to spend a couple of minutes just carving this up, shaping it to fit this battery. Okay, so I've just spent a few minutes shaping this piece of high density foam into a slot which will house the battery. I've just made a cutout so that you can have the connector in there. But that now just leaves us to connect up the battery. And these super seal connectors make it really easy to disconnect your battery from the box. It's a case of clipping on the super seal connectors, joining up the battery. Then we can just pop the battery into the foam there. You can just tuck the connectors out the way and pop the lid on, clip that down. That battery is now firmly housed. I can flip that around, shake it around, the battery's not moving at all. So it's nice and secure within that box now. And there we go, that's the finished waterproof battery box to house the lithium battery I'm using there, but could equally be used with a sealed lead acid battery or an AGM battery, gel battery as well. Same principle would go for any of the 12-volt batteries. We've got that nice waterproof socket on the end with this cap. You can unscrew the cap, reveals the socket. It leaves it just to wire on the plug onto the end of your 12-volt device. In this case it's going to be a fish finder for a kayak. And once done, that can just plug on, screw down, and you've got 12-volt power to your device. Really neat, simple system. And with it being lithium iron phosphate battery, it's really lightweight. If I just pop this whole setup on the scales, I'll remove the plug there a second. Total weight 1,803 grams, so 1.83 kilos, 1.8 kilos, sorry. So that's 400 grams lighter than a 7 amp hour sealed lead acid battery on its own. And those are about 2.2 kilos on their own. So this one coming in at 1.8 kilos, much lighter, but as I mentioned, 7 amp hour. 24 amp hour equivalent, nearly 3.5 times the amount of charge this battery will hold. So much more charge for much less weight. Awesome. That's going to power my kayak fish finder. I'm just going to wire up that plug now to the fish finder. We'll plug it in and we'll give it all a test. Right, so it's time to test the battery box on my new fish finder, the Lowrance Elite FS7. So I've got that waterproof plug, the Bolgin 2-pin plug. I've wired that onto the power lead for the fish finder. It's now a case we can just undo the caps on both the battery box and the plug. The plug will only fit one way onto the socket so that you won't get cross polarity. You'll get positive to positive, negative to negative. It's a case of screwing that in. Creates a nice waterproof seal. That's plugged up. Can now just turn on the fish finder and make sure everything works. There we go, there's a beep there. It's loading up. Yeah, battery box all appears to be working, powering the fish finder, no problems at all. Awesome, all working fine. Great, so we now know that the battery box is powering my fish finder, all fine. However, next part of the testing is to make sure that this box is waterproof as I need it to be. Now, on a kayak, on my particular kayak, this box is going to be stored inside the hull, inside one of the hatches. Now, it's not going to be very wet in there. There's, you know, occasionally a little bit of water sloshing about, but it's mainly just a damp environment in there. So it's unlikely to get any sort of real water pressure on this box. However, I'm going to test it by just submersing this box. I've got a big tub of water here. Going to submerge the box and leave it around half an hour or so, and we'll just check for any water ingress, just to make sure that the battery box is fully waterproof and fit for purpose for storing a lithium battery or any battery. Okay, so this box has now been submerged for actually just over an hour now. So I'll now take it out and make sure no water has found its way into the box. Okay. It's looking good so far. Just give the outside a quick wipe. Let's open it up. Okay, that is bone dry. There's not a drop of water in there at all. Brilliant. The box is completely waterproof. That means it's up to the job, keeping my battery nice and dry whilst kayak fishing. Okay guys, so there we go. That's the waterproof battery box, made and tested, all working really well. Yeah, I've opted for a lithium iron phosphate battery here, but this battery box would work just as well with a sealed lead acid battery. Yeah, really easy, simple box, easy to use. You can easily disconnect the battery from it for charging using the super seal connectors, and yeah, dead easy to plug your fish finder in using the plug and socket system there. So yeah, lithium iron phosphate batteries, worth considering if you want to save some weight on your kayak. The one I've got in there, equivalent of a 24 amp hour sealed lead acid battery. This whole setup with lithium iron phosphate weighs about 1.8 kilos. To get the same with a 24 amp hour sealed lead acid battery, you're probably looking at somewhere between 7 and 8 kilograms. So it's considerable weight saving, something like a 70 to 80% weight saving by going to lithium. But downside is it costs a lot more. But yeah, there we go, waterproof battery box for powering the electronics on your kayak. I will mention I'm using a lithium battery. You've got to ensure you're using a correct charger for charging any lithium batteries, lithium iron phosphate or otherwise. The one I use is an Oxford, it's an Oxymizer 3X. This will do sealed lead acid batteries, anything from small batteries up to bigger car batteries, where it can also be used with lithium iron phosphate batteries as well. So that's a good little one to look at. Oxford do a range of chargers, so yeah, take a look at their range and just ensure that you're looking getting one that's suitable for charging lithium iron phosphate batteries if you are using a lithium battery. Okay guys, hope you found that video useful. If you did, make sure you hit subscribe on my channel and like the video. There'll be plenty more videos coming just like this, showing installations, DIY, rigging, etc. So yeah, really appreciate it if you can hit subscribe and follow my channel. If you've got any questions on my battery box build, just comment below. I'll do my best to answer. Okay, thanks for watching.